use media all the time in biomanufacturing. It's the nutrient-rich liquid or gel that helps cells grow, sort of like a protein smoothie for cells. Today, I want to show you how to make a medium that's commonly used for growing bacteria, lysogeny broth. Often, we just call it LB+. But I also want us to think about the impact of pharmaceutical formulation. That's the process in which chemicals and substances are combined. The order in which we add ingredients makes a big difference. Always be sure to wear your PPE, lab coat, gloves, and safety glasses. Let's start by weighing out our first 3 ingredients. We need 1 gram of tryptone, 0.5 grams of yeast extract, and 0.05 grams of sodium chloride. If any of the ingredients get stuck on the side of the beaker, just rinse them down with a little deionized water from a squirt bottle. Let's add some more water, 80 milliliters, and mix the solution gently for a few minutes until it's dissolved. LB Plus needs a neutral pH, 7.0 plus or minus 0.5. We don't want to put the pH meter probe into the stock solution because that could introduce contamination. So instead, pour a small amount of the sample, about 10 milliliters, into a clean beaker and test that. The pH of 6.01 is a little low, so back at the media, add 0.2 milliliters of sodium hydroxide and test the pH again. A pH of 7 is what we are looking for. Pour the media into a graduated cylinder and add deionized water to get the final volume of 100 milliliters. We're going to divide the media into 4 bottles. Pipette 25 milliliters of media into each and cover them with aluminum foil. This way, we can't see what's happening to the media until the very end when we have a big reveal. Ooh, the anticipation. Each bottle of media needs to be autoclaved and receive 3 more ingredients: glucose, calcium chloride, and magnesium sulfate. But here's how we're going to test the impact of formulation. Let's add the ingredients to each bottle in a different order and see if it makes a difference. Place autoclave tape over each cap. Bottle 1 is going to the autoclave next, so loosely cap it. Add the glucose to bottle 2. Add the calcium chloride and magnesium sulfate to bottle 3, and add all 3 ingredients, glucose, calcium chloride, and magnesium sulfate to bottle 4. Sterilize the media using the slow exhaust cycle on the autoclave. Now that the bottles have cooled, let's go back and add the remaining ingredients to each bottle. Bottle 1 still needs the glucose, calcium chloride, and magnesium sulfate. Bottle 2 needs just the calcium chloride and magnesium sulfate. Bottle 3 gets the glucose. And bottle 4 already has all the ingredients, so just give it a swirl. Now each bottle contains the same ingredients. The only difference is the order in which we added them. Okay, it's time for the big reveal. Remove the foil. Okay, wow, they look like 4 completely different solutions. Which one do you think we formulated correctly? Bottle 1 is our winner. The media is clear and it's ready to support bacterial growth. So what's the key difference? We waited until after the autoclave to add the final 3 ingredients. But bottles 2, 3, and 4 each contain ingredients that were basically cooked by the autoclave. That's why we see these red, caramelized colors, and that means they won't work for growing cells. Having the right ingredients is important, but adding them in the right order, well, that makes all the difference in biomanufacturing, and even in smoothies. Thanks for watching.